I'm going to explain the concept called as photodiode. Now, first understand what you mean by photodiode, what is the application of photodiode, and where we are using this photodiode, how the photodiode works. So, if I proceed with the definition of photodiode, a photodiode is a semiconductor PN junction device that converts light into electrical current. So this is a diode which is used for converting light to electricity. So the name itself indicates photo means light, diode means it is a semiconductor PN junction. So how this will do, how it is going to convert the electricity from the light. What is the internal structure of this photodiode and how it is going to work? So if I see the picture of the practical photodiodes. So these are the practical photodiodes. When you observe the photodiode, there is a window will be there. This window is going to allow the light to fall on the junction. So when you see any photodiode, there is a transparent window will be there. So that window is going to allow the light to fall on the junction of a diode. The symbolic representation of photodiode will be indicated like this. So here the anode and cathode terminals are same. Only one additional thing is added to the symbol is the light arrow. This is an arrow indicating that light is going to fall on the junction of a photodiode. Now if I proceed with what is the application of these photodiodes. If I take almost all electronic appliances, we'll go ahead with using the photodiodes. So if I take medical appliances, so here the medical appliances such as like microscope, whatever the medical related equipments we are using, there we are going to use a photodiodes. Similarly, another application like in the TV also we are going to use a photodiodes. And similarly, if I am using a AC air conditioner, in the air condition as well as remotes, we are going to use a photodiodes. Now, photodiodes mainly uses for remote applications. If you take any remote applications like TV remote, projector remotes, or whatever the remotes are available, that remote contains photodiodes. Now, as I told that photodiode, it is used for converting. Now, what is the internal structure? How this photodiode works? So here, if I see the internal structure, this is also consisting of P-type material and N-type material. But there is a window open for light to fall on this junction. So this is a difference in the construction. And remaining construction wise, it is same as the diode construction only. Only the difference is here we have opened the transparent window to allow the light to fall on the junction. So if I proceed with, if I take two P-type material and N-type material, now what happens? So first, when light falls, initially, there is a barrier potential. When light falls on the junction, the light is going to free the electrons it is present in the barrier. Once the electrons become free, then what happens? It starts moving from one side to another side. How it moves? Here we are using external potential. This external potential, what it is going to provide? It is going to attract this positive terminal of the power supply attracts the electrons, whichever the free electrons are there, that is going to be attracted by positive of power supply. Whereas negative of power supply, it is going to attract the holes. This movement will create the current to flow. So that is the way the photodiodes is going to work. So if we observe this is a diagram where when light is fallen on the junction, the excess electrons will be generated, electrons and holes will be generated. So that excess electrons and holes is attracted by the external power supply. So this is the way the current flow will take place in the photodiodes. Now we know that photodiodes are going to be used in the reverse bias condition. So the reverse bias condition is used when you use a photodiodes. This diagram indicates the voltage versus current characteristic of a photodiodes. So here a voltage in the positive side, this is a voltage in the negative side. Now we are concentrating on this voltage because the photodiode is operating under reverse bias condition. Similarly, the corresponding current, what is the current that is going to occur in the photodiode? This is indicating the negative current. If you see this VA characteristic of photodiode, initially there are something here, it is indicating P1, P2, P3, P4. What is this? I will tell now. So before that, there are a different possibility of light to fall on that photodiodes. If I kept the photodiode in a dark room, if I connected external source also, if I kept it under dark room, at that time that photodiode will not conduct. But there is a current will flow due to the minority charge carrier. So there is a possibility of current to flow in the photodiode due to the minority charge carrier when there is no light fall on the photodiode. So that current we call it as a dark current. So what is the reason we call it as a dark current? Because the current is generated, still there is no light. So that current we call it as a dark current. There is another, if light is going to fall on the photodiode, then how the performance of this photodiode will going to do? The intensity of the photodiode working, the current flows through the photodiode, it depends on the intensity of light. So if I see the intensity of light also going to vary from time to time. You know that the sun will rise in the morning 6, and when it reaches at the evening, almost all intensity is same. If you observe at the midday, like from 11 a.m. to 2 p.m., the intensity of sun is more. So that means similarly, the photodiode working also changes with respect to intensity of light. Here, if intensity, here I am considering there is that intensity is indicated with P1, P2, P3 and P4. Now, if you observe this relation, when P4 value is more than the P1 value, that indicating that intensity of light is more. P4 intensity of light is more when you compare to P1 intensity. If the intensity is low, means here in this graph, what it indicates, the current is less compared to P4. So if I assume this current is, I will consider it as 2 milliamps. So at this point, I am going to consider this current is 4 milliamps. So when the intensity is more, means the current flows through the photodiode also more. So that is an indication we found from this graph, VA characteristic of photodiode. It is indicating that when the light intensity increases, the current flows through the photodiode also increases. When there is no light, means that current we call it as a dark current. So this is a